you're struggling with organic chemistry or just want to improve your knowledge base, or even just want to make sure you keep getting those A's, well, then stay put because you're in the right spot. Let's do some predict the product practice reactions. So this is actually a reaction I've ran in real life, and it was one of the first reactions I was given individually during my PhD. So let's walk through it. So based off all this, can we predict the product? So we have dimethylmalonate. Then first step is sodium hydride with allyl bromide, and it's 2.5 equivalences. And then we have a sodium hydroxide step, and then an acidic workup step. What does that look like? Looking at the first step, what do we have here? We have sodium hydride, which is a nice strong base, and then we have allyl bromide, which is a haloalkene. And very important, it is in 2.5 equivalences, which means it is in excess. So our diethylmalonate is our limiting reagent. I'm sorry, not diethyl, dimethylmalonate is our limiting reagent. So sodium hydride, nice strong base. It wants to go find some protons. Well, where is it going to get them? So this position right here, this alpha position has two protons that are super acidic because this right here is electron withdrawing both those carbonyls. So it's going to grab one of those protons. Then that's going to have a negative charge sitting right there. Then we have our allyl bromide. That negative charge, oops, wrong one. Our negative charge is going to attack that in an SN2 reaction and form our intermediate product, which I'm just going to give a kind of crude drawing of it. We're going to have this where we have an allyl group that was once there and then a proton. But because this, remember we said this is in excess, that will happen again. So then it ultimately gives us this final product right here. I'm not sure what the IUPAC name for this is. I'm going to be totally honest. But what I used to call it is diester diene because we have an acyclic diene right here, alpha omega diene, and then we have two esters, so diester diene. The second and third step, they're two separate chemical reactions, but when you run them in the lab, it's kind of part of the same whole thing. So we have our diester diene right here, and we're going to expose it to sodium hydroxide. So that's basic conditions. And I didn't specify a solvent here because you could use a couple different solvents. But what that is going to do is that is going to cause a base-catalyzed hydrolysis. So that's going to kick off these methoxide groups, and we're going to hydrolyze that ester. And then what we're going to have is we're going to have our alkene. It's a really crappy drawing. And what we're going to get is a carboxylate, a dicarboxylate. And that is because a base-catalyzed hydrolysis is irreversible, and I'm not going to go into the mechanism right now, but it is. And if you want to know the mechanism for base-catalyzed hydrolysis, I can make you a video for that later, or it should be pretty easy to find in your textbook. If not, just DM me, I can go through it with you. And then for the second step, we have H3O plus, which is generally just signifies an acidic workup. So what I did in the lab is I just dropped in concentrated hydrochloric acid. And then what that does is that protonates this right here and then gives us this product right here, which is a dicarboxylic acid alpha omega diene, which I just called diacid diene. So that is our final product. To recap, I'll predict the product with this reaction right here. We have our dimethylmalonate. For our first step, we have sodium hydride, which deprotonates at this alpha position here. We undergo an SN2 reaction with this allyl bromide, but there is 2.5 equivalences, so it's in excess. So the sodium hydride deprotonates the second proton. We undergo a second SN2 reaction, which gives us our intermediate diester diene. And then sodium hydroxide comes in and induces a base-catalyzed hydrolysis, which is then converted to the final product here, this diacid diene, through an acidic workup. All right, I hope that was a good video for you guys. If you have any questions, you can drop them below in the comments or you can send them to me through DM. I'll try to get back to all of them. If you have any questions with organic chemistry, you can put them in the comments below as well, or you can DM me and I will try to get back to you the best I can, or I can make a video about it and walk you through that.